Yeah, so today I'm going to be talking about Kitchen Salt and Pytest, and using those two tools to be able to easily test your salt states. So who am I? My name is Megan Wilhite. I'm mostly known as Shell on the interwebs, but no, that's not short for Michelle or anything. It's a video game reference. And I'm currently a software engineer at SaltStack. Before this, I was in the DevOps world, and I used Salt and fell in love with it. And when I had the opportunity to jump over, definitely took the opportunity and have loved it ever since. All right, so for those that might not know what Salt is, I was just going to give a quick overview of what it is. It does a lot of things, but mostly it's an automation platform. It helps orchestrate things. It can do remote execution, and it's also known for config management. So what is a salt state? So it's a way to kind of define what state you want a system to be in. So for example, you want certain packages installed, services set up, and so forth. So I have a small example here of what a salt state looks like. And as you can see, it's in YAML, and all it's doing is it's trying to install the Apache service with the package.installed, and then it wants to make sure the service is running, and then it's also trying to set up a user and group. So that is a small example of what a salt state is. Salt states are used a lot within Salt, and a lot of people struggle with trying to test these because, if you edit these states and you run it against a production environment and, say you put something in your state you didn't mean to, it can bring down your production environment. So it's really important to test your salt states. And I'm going to be showing a way to do that with Kitchen Salt. All right, so what is Kitchen Salt? Kitchen Salt actually is built on top of Test Kitchen, which is Chef's implementation that they use for testing. And I'll kind of show you where Kitchen Salt comes into play and where Test Kitchen comes into play when this is getting this set up. Okay, so other than just installing Kitchen, which is a little bit outside the scope, there's a bunch of great getting started that you can follow to install it. But besides installing it, the one other thing you'll have to do is set up a .kitchen.yaml file in the root of your project, or wherever the kitchen command is going to be run, because it looks for that file when it runs. And there's a couple things that you'll need to define in this file, and we'll go over them in more details, but your driver, your platforms, your suites, your provisionary, your verifier. You can also define a transport. In this demonstration, we're not going to be doing that because we are using the default, which is SSH. But there's different other transports that you can use, like SFTP, WinRM, if you're using Windows, for example. So yeah, let's go ahead and dive into all these different settings. So the first thing you need to define is your driver. In our example, we're going to be using the Docker driver. Now the driver kind of just defines like what VMs/containers you're going to use to run all your tests against. And if we go ahead and look at Test Kitchen's documentation, you can see all of the other drivers that you might have access to. So it's not just Docker. You have access to run these tests against different clouds such as DigitalOcean, EC2. There's even a Vagrant driver. So those are all your different options. In this example, as you can see, we're just going to be defining Docker. As you can see, we define that we're not going to use sudo, but if you have a container or VM that you need to, you'll need to make sure that's set to true. We're using a privileged container in this instance because we're trying to set up systemd. I'll explain a little bit more later, but essentially Salt, when it's installed, we want to be able to install the systemd service. So that's why we have it set up that way. And then we're using the root user. And another step we are doing is we're forwarding the port 80 because in the demo, I'll show you, we're going to be setting up an Apache web server. So we want to be able to forward that port so we can query that website once it's set up in the container. The next thing you'll need to define is your platforms. And this is just the distributions that you want to test against. In our example here, we've only have one platform, but you can define more than one. And as you can see, we're testing against Ubuntu 18. Then you'll want to define all your different test suites. In our example, we only have one, and we're naming it Salt-Apache. That's arbitrary. You can name it what you want. But the reason, for example, that many people might have different suites set up is you can test against different Salt versions, for example, and you can define different things underneath each of these suites. So that is a suite. And this is where Kitchen Salt comes in, is the provisioner. This is the provisioner, it's called Salt Solo. And within here is where we're going to define all of our salt options that we're going to be using and testing against. As you can see, we are using the Bootstrap install. And for those that don't know, Salt just has a Bootstrap script that you can use that makes it easy to install Salt. You can also change it from a Bootstrap to Yum or apt, for example, so it just pulls down the Salt packages from a repo. And then also in this example, we're passing a couple of options to the Bootstrap script. In this particular example, we're doing a git install, and we're going to be defining the version that we want to test. And then we're just passing -q, which is quiet, so don't show us as much when we do the git install, and the X is defining for the services not to start up, because in Kitchen Salt, it's just going to run salt calls, so you don't need the service to actually be running. And then on the next line there, you can see we have log level debug. That's going to just define the log level that we see on Salt's side of things. And then in this example, we're using is file root. What that's going to do is it's going to copy everything from a project from the root of the project to the container and treat that as Salt's file root. And what Salt file's root is, it's where it looks for all the states that it needs to run. And then another thing we're defining here, state top from file, is we're saying, hey, instead of defining what the top file looks like here in this configuration, let's go ahead and just grab my top.sls file in my repo. And what the top.sls file is, it's just a file that will list off what states we want to run. So that's that. And then another important one there is we're defining a copy filter, because we don't want to copy everything to the container, you know, things like the .git directory. It's just going to slow things down and we don't need it there. To kind of show you a different example, what a lot of other people like to do as well is they'll define their top.sls file in their provisioner. So as you can see in this example, they're just defining it. And this is what a top.sls file looks like for those that don't know. The base is Salt environment that you're going to be running these against, and base is the default environment. And then we're going to be targeting against all minions in this case. And in this example, he is running all the WordPress state. Another thing that I don't show off in my example is the use of pillars. And you can define these as this example shows. You can define the top file like this. You can also define pillars from files like it's showing here as well. Okay, so that's the provisioner. That's the bread and butter of Kitchen Salt, and kind of where we get the power from Salt to test it. And then we're going to define our verifier. The verifier is going to test everything. So when we do what's called a converge, it's going to install Salt and run the states. And if that passes, then we're going to run the verifier. And the verifier is just a way to verify that your states were set up correctly. In our example, we're using the shell verifier, and we're defining the remote exec to be false. And what that means is we're going to be running the tests in this case on my laptop against the container, instead of running the test on the container. And then we're going to define our command. And as you can see there, we're just running Pytest, and we're running all the tests that are in the test directory. Okay, so a couple of commands you'll need to be familiar with once you have your kitchen YAML file all set up and ready to go. KitchenList, this will kind of show you all of your test instances and what state they're in. Are they converged? Are they set up? So forth. Kitchen create will just create that instance. Kitchen converge will actually install salt and run the states. So it's that provisioner part. Kitchen verify will run those Pytests that we've defined. Kitchen login will give you the ability to log into the VM. I use that a lot if I'm troubleshooting something, maybe something's not working, log in, see what's being copied over, and so forth. And kitchen test actually combines a couple of these commands. So it'll do like the create, the converge, the verify, and then it'll only delete the VM if the test pass. So it kind of puts them all in one. All right, so let's go ahead and demonstrate that. So I have just a project here, and it's called Kitchen Salt Demo. And if we look at this, we can actually look at the kitchen YAML file so that you can see it in its entirety. These are pretty much all the same settings that I showed in the slides. But to kind of go over it again, we've got the driver here, we're using Docker, we're using the provisioner, and we've set up all the settings, what we're going to install, what we're going to run. We've got the Ubuntu platform, which we're also going to be running System B on. And we've defined all our test suites, and we have our verifier. So this is what the kitchen YAML file looks like in its entirety. And when we run kitchen, it's going to look for this file. So let's go ahead and run KitchenList. Okay, so as you can see here, this is showing us the name of our instances, the driver that we're going to use, the provisioner, Salt Solo, our verifier, our transport, and then it's also going to show us like what was the last action and if there was any errors. If we were to edit this kitchen YAML and we add another suite, for example, let's call this Apache 2, it'll show that in the list. So now you have 2 test instances, as you can see there. But we're going to go ahead and delete that for now. So in this instance, we only have 1 test instance that we're going to be testing against. But as I showed, you can create more, and you can create more operating systems and so forth. One thing that I do a lot is I'll just do kitchen converge instead of create then converge, because converge will create the VM, or in this case container, if it's not created, and then it'll do the converge as well. So I usually just go with that command. So we do kitchen converge and then the name of the test instance that we want to converge. All right, so it's setting this up. It's setting up the container. We've successfully built it. Now it's actually installing the salt minion. And that's going to take a little bit. So let's go over and show you what states this converge step is actually going to run. So in my repo, I have my top file. And as you can see here, our top file is defining what states are we going to actually run. So we've got base environment, that's default. We're targeting all minions, and we're going to run our Apache states. And as you can see in the directory, we have our Apache folder. And if you look in here, we have a couple files. When you define a state, you can define it, you can name it either apache.sls or you can do apache /init.sls. And in this case, we've used init.sls. So when we look at this init file, we can see that all we're doing is including a couple of other states. So we're going to include the Apache install SLS file and the web content. So let's go ahead and take a look at the install state. So as you can see, we're using a little bit of Jinjit here. So we're just defining this web server. variable within this state. And all we're doing is we're just setting up Apache 2 on Ubuntu, and then we're just making sure the service is running. Very simple. And then the web content state, what we're doing is we're taking the index file and we're just managing this file and we're adding these contents to it. So once everything's converged, we should be able to see our website show demo worked. So let's go ahead and see. Oh, perfect. So it's installed Salt, and now it's actually running the state right now. It looks like it's probably trying to install Apache right now. You can see that it's rendered some of the files. So we'll let this run here for a second. It should be done in a bit. And as you can see, we're also seeing the debug level of the Salt logs. So that's useful when trying to debug things. All right, perfect. So everything passed. And as you can see what was returned. You can see that we installed Apache 2. It also shows all the other dependencies that it installed alongside it. It started the service and said, oh, we're actually already enabled. And it is managing the index file. Perfect. Now we should actually have a container that is running. So let's go ahead and see that container. We can see the ID. What I'm most interested in is what port it's forwarding to for port 80. So let's go ahead and see if we see our website. And once I click this, we should see demo worked. Yay. So everything's defined correctly, the container's running, and we didn't have any hiccups. So the next step is now let's go ahead and verify it with our Pytest commands. So before we run that command, let's go ahead and talk a little bit about Pytest. You don't have to use Pytest in the verifier. You can use any sort of test framework that you want to use. But in this instance, we're going to use Pytest. So Pytest is just a test framework that you write Python in. So let's go ahead and show a really small example before we show the test that we're running. So here's a really short example. You can just use Python's normal assertions here. And as you can see, we're just literally just asserting that hello world equals hello world. So string equals a string. And then we have another test here where we're saying is true a Boolean instance. So really simple. This is just a small Pytest example. So when you run Pytest, how does it actually discover all of the tests to run? So it does a couple of things. First, it checks for any file names that start with test underscore or end with test underscore or underscore test, sorry. And then within those files, it looks for any test method that starts with test. And as you can see in our previous example, both of our tests start with tests, so it will run those. There's a couple of different ways you can run Pytest. If you're in the directory, you can just run Pytest, or you can define pass the directory's name like we did in the verifier. You can also just pass the name of the file. There's other ways to run this, but one of the more powerful ways to run Pytest is you can do some substring matching. So say you want to run all of your tests that have the name instance in them. You can just pass -k and instance, and it will find all those tests and run them. So that's a couple of different ways how to run them. So let's go ahead and show that off. All right, perfect. So I have this Pytest directory, and we have a couple files in here. PyCache is just the cache it's using, so you can ignore that. Conf test we'll talk about in a second. Test fixture we'll run into in a second. We just want to focus on test 1. And as you will see, this is exactly the same as what we've displayed in the slides. So once again, we're just asserting that strings are equal to each other and that true is a Boolean. Okay, so if we run Python by itself, it's going to find both test fixture and test 1, but they should all pass. Oh, whoops, Pytest. All right, perfect. So it shows you a couple of things here. It's going to show you your Python versions, things like what are plugins you have installed, your tempter, redir. It'll tell you, oh, it collected 4 items. It will show you the test file that it ran. Usually I like to run Pytest with -b because it will show you the individual tests that it actually ran and whether that individual test passed or failed. So let's go ahead and show when the test fails what Pytest is going to display for you. So let's just go ahead and change that to a lowercase h. And when we run, we should see a failure. Perfect. So it showed us, okay, we have test hello world is actually failing, and then it's going to show you the assertion error and where the failure is. And we can easily see, oh, it's the problem is lowercase h versus uppercase h. And if we change that back, we should see that pass again. So that's just a small example of how you can use Pytest and run against it. As I showed in the slides, you can also just pass the name of the file. You can also just run one test by defining the file name and then the test method. And there you go. So it only ran, you see it even better with -b. You can see it only ran that test. Okay, so one other filter we showed on how to run Pytest is with substring matching. So let's go ahead and show that. Let's say we only want to run the tests that have the word instance in them. We can just pass in -k instance, and you'll see that only that one test ran. All right, so that is Pytest. Okay, so let's talk a little bit about another feature of Pytest called Pytest fixtures that are really useful. Essentially, it's gives you the ability to run code before every test method. In our demonstration, it's going to be a much simpler example, but a lot of people will use these to initialize databases and things like that before running tests. And the way you call out the test fixture is you include it as an input parameter to your test method. And we will go ahead and demonstrate that. So this is our file where we're defining our Pytest fixture. As you notice, we had to import Pytest because we're calling pytest.fixture. So as you can see, it's a decorator. And so now we have this values fixture. In this example, all it's doing is it's just returning 10. And the way that we're using this fixture is in our test methods, we are calling out the name in the input parameter. So now we're able to use it and we can assert, hey, this value is equal to 10 and this value is greater than 9. So let's go ahead and just run that one file and we can see, okay, perfect, they passed. What if we want to use this test fixture in another test file? So in our first file that we had, let's see what happens when we pass in the values fixture. This will actually fail because it does not see the fixture in the other test instance. And as you can see, it fails and tells you, hey, the fixture values was not found. So one way to get around this is if you have multiple test files that need to access a test fixture, you can define them in Pytest conf test. Now, conf test can be used to define a lot of other things that Pytest, you can use in Pytest, like plugins and hooks and things like that. But for this test case, we're just going to show off the fixture. So this is the exact same fixture that we used in that other, the test fixture file, but now it is defined in conf test. So now that we have it defined here, we should not see a failure and it should pass. And even if we comment out the fixture on this file, because it's in Conf test, it should pass as well. So that is a very simple fixture, and they're really powerful within Pytest. So let's go ahead and demonstrate how we're using fixture and Pytest within our verifier. All right, so as you can see, we have this test directory in our kitchen salt demo. Let's just go ahead and show what's in there. And we have a conf test, and we have a file named test Apache, which is going to run the actual test. Let's go ahead and look at our conf test. Okay, so it's doing just a couple of things here to set up our test. We're using a module called test info, which helps you to test against Salt, Ansible, Chef, all those things. In this instance, we're just using it to query the container that we're setting up. And it'll give us the ability to like find out what certain files are in the container, what services are running. It just returns a test info host object that we can play with within our test. So that is our host Pytest fixture. Then we have a port Pytest fixture, and all that's doing is it's running the docker port command so that we can find out what port 80 is forwarding to, and we're returning that port. And then here we're just returning the URL. We're passing in the port fixture, and we're returning just the URL that we're going to test against. So that is the conf test. So now if we look at test Apache, we'll be able to see us using those fixtures. So in this test, all we're doing is we're passing in the host fixture, and we're just making sure that the service is running. It is Apache 2 running. And then in this fixture, in this test, we're also using the host fixture, and we're trying to see, we're grabbing the index HTML file, and we're just making sure that it contains demo work. So when we set up this container, we run the states, we know that demo work should be in this file. So we want to make sure that's the case. So that now we're passing in the URL fixture, and we're just using the request library to query against the actual website. And we want to actually see if we're returning a 200. And that's all this test is doing. And then we have another test that's getting the text of the website by querying it as well and making sure the contents are also including demo work. Awesome. So now we have all our Pytest set up. And if we look at our kitchen YAML again, we can see that we're just running pytest-b, and we're pointing it to the test directory. So now when we run kitchen verify, it's going to run all those Pytests, and it's going to run them on my laptop because we've set that remote exec to default. And perfect, everything passed. It ran all of these tests and passed. Let's go ahead and just demonstrate what a failure is going to look like. It's going to look exactly like you would expect Pytest failure to be. So let's return this status code to be at 400. And if we run verify again, it shouldn't fail. Perfect. So it tells us, hey, you were wanting 400, but you got a 200. And let me just change this back really quick. Once we change that back, we run a verify, and everything passed. So that is Kitchen Salt in its entirety. You can take this a step further and add it to your workflows. One thing I did is I did add a Travis YAML file, and I set up Travis CI to run my tests anytime I put a pull request into my repo. So I've just defined, hey, run a kitchen converge and a verify, and then make sure you destroy it in the end. So let me demonstrate that really quick. I have a PR here that I set up beforehand, and as you can see, it passed all of my Travis tests. And if we go look at that, you're going to be able to see all those commands we ran individually. They were run within this Travis CI workflow. So you can see, it's cloning the repo and all of that, and then we're installing salt. That takes up a lot of the context of the console. And then right here, we are running our states. So we're rendering some files right now, and we're seeing the same thing as we saw when we ran it individually. It installed salt, it started the service, and it's managing that file, and then we run a verify, and we can see here that it's passing as well. So we know before we merge this, which I can go ahead and merge now, that the tests are running and we can merge this now, and our states won't break anything. All right. All right, so that is all I have to demonstrate Kitchen Salt and Pytest. I will mention that at Salt, we do use Kitchen Salt for our test infrastructure, and a lot of we have different repos that just run states to set up our test infrastructure. And before we were having a lot of problems, the states weren't getting tested beforehand. When we implemented Kitchen Salt, obviously those sort of problems stopped happening because we made sure that the states actually worked before we merged it in. And it's been a really great tool to have around. So are there any questions?